Motion analysis, if you look at this graph of the hips here, this is X versus T, this is Y versus T. X is for the displacement in the X direction. What do you notice about the shape of this graph? It is a what? Curve or a straight line? Everybody, easy, right? It's a straight line and it goes up and to the right. In math class, what kind of relationship is that called? That is called a linear relationship. For a sprinter, that's actually pretty good. If it went up and then came back down, that means the guy went forwards and started doing what? Going what? Backwards. That's not good, right? That's not a good way to run the race, right? Now, the other thing that I notice is because it's a straight line, that means in equal intervals of time, he's covering equal distances. He's running at a steady speed. So if you're sprinting, you want to get to your top speed. That's good to see. Now, how about in the Y direction? What do you notice about this graph? It's also a what? Straight line, right? But is it a linear relationship that's increasing, or does it have a slope that's pretty flat? It's got a slope that's pretty flat. So what does that tell me about the motion of the hip in the Y direction? Is it changing up and down, or is it staying nice and level? Which one? Nice and level. That's good, because I don't know about you, but if you're sprinting, you don't kind of, you want to pop up and down, because you'll look like goofy, right? And you'll probably lose the race. So what's nice is, as a coach, you can correct small errors in technique. It looks like there's a little dip here, but I think that's actually pretty normal just for the human body moving, okay? Now the hip's actually pretty simple. If we look at something more complex, like the right ankle, that's the one that's in the red here in the front that's getting whipped around, okay? Notice, is this shape as simple now? Is it just straight lines, or are there curves now? There are curves. So if it was curving just up like that, we would call that an exponential type relationship. And it's curving back down in the Y direction because the ankle is getting whipped down. So when you see curves there, usually on a position time graph, that's a sign of acceleration. You see that? And so for a coach, having quantifiable data and graphs, we can look for errors in technique. And I actually I'm not a track coach, so I don't want to like make up something wrong, but I think how you pace out your stride length and whipping your ankles across the ground, it definitely affects whether or not you win a sprint there, especially in a 100-meter sprint, it's so short. So today what we want to look at is breaking down the basics of motion graph. So on